Welcome to the solution set for CK12's Algebra unit, working with rational expressions. Notice that the rubric is based on the mastery level, not on your percent score. CK12 will just say do 8 questions or 10 questions. So in this case it would be 10 questions correct. If you get 10 correct, CK12 will tell you that you have 100%. I'm scoring by the mastery level that we'll see in the corner. That's our skill level up here. So here we want to perform the indicated operation and simplify as much as possible. So for this, we're going to want a scratch pad. Now we have a negative 5x plus 30 over x squared plus 11x plus 30. So here we have a negative 5x plus 30 over x squared plus 11x plus 30. And we are adding 2 over x plus 5. So as with any fractions that we've ever worked with, we want to start by putting them over a common denominator. So we'll factor out our numerator here. And our denominator, two numbers that multiply out to 30 but add up to 11, are 5 and 6. Now notice the x plus 6's can cancel. So this becomes negative 5 plus 2 over x plus 5, or a negative 3 over x plus 5. So that is B. We check it, we're good. So now perform this indicated operation and simplify as much as possible. We have an x plus 7 and an x minus 7 as our two factors in the denominator. They look related, and we could use difference of perfect scores when you multiply them out, but they are not the same. Right? If x is 10, then this first fraction is 6 over 3, or 2, and the second is 6 over 17, which is not 2. So when you put them over a common denominator, we're going to end up with an x squared minus 49 in our denominator. Now the fact that we have a 6 minus 6, when we multiply them out, all we're going to have left is the negative 42 minus another 42 here. Right? Or actually in that case it would be a positive 42 plus the 42. That's how we get our 84. But this is the only one that has the right denominator of x squared minus 49. And we want to find the excluded value. Here, that excluded value is 0. We cannot divide by 0. Notice now, our gauge is here. We have the first indication of our mastery level. For a perfect score, we need to finish with this in mastery. And we want to input the function into your graphing tool carefully and accurately. So, when they're saying the graphing tool, that means we are expected and allowed to use technology. So let's do that. Just bring these in together. Do a quick login, just because that would allow us to share it. Now we have a negative x cubed minus 8x squared plus 2x plus 8. X cubed plus 8x squared, I believe it was. Oh no, it's minus 8x squared. Plus 2x plus 8. And our denominator is x plus 2. There we go. So now, any asymptotes that we have, we don't seem to have any asymptotes. This has just become a somewhat typical looking cubic equation with a single root. Notice though that this is expecting them. Right, we do have the asymptote at x equals -2. When x equals -2, we're dividing by 0. There's the rest of it. When we scroll way out, we can see another graph on the other side. But x equals -2 is indeed an asymptote for us. It will never cross that line. Now, only one of these has x equals -2 as an asymptote. So we don't have to bother looking at the rest. Now, this one, we've got a -6x cubed plus 8x squared plus 7. Let me just turn these off. So, -6x cubed plus 8x squared. Oh, it needs to still be in the brackets. Plus 7. And it's all over x squared. So this one, our asymptote is a little more obvious at x equals 0 here. But notice in each case we have two listed asymptotes. So that's the question, is our asymptote going to be a -6x plus 8 or a positive 6x minus 8? Well, we could graph that. That doesn't appear to be an asymptote to our function. If we graph the positive version, well, there we do have an asymptote. And after we finish our work in polynomials, we'll be able to determine why that is. But this is our function with its asymptote. So now we are looking for our asymptotes, our wholes. So what we have here, the vertical asymptotes are going to be when our denominator is dividing by 0. So that will be the cube root of positive 2. So that eliminates option B. And we also have various x and y intercepts to check. So let's take a look at them. Notice that 1 plus and minus 1 are much more common than 3. And now that we know our asymptote is at x equals the positive cube root of 2, we can uniquely determine the solution based on that x-intercept. That's the only difference. So the x-intercept is where y equals 0, and that happens where our numerator is 0 and our denominator is not. Our numerator is 0 at x equals 1. At that point, our denominator is a -1. So x equals 1 is the correct x-asymptote, or x-intercept. Okay, we are at the mastery level, so we could stop and hand it in incomplete, and we'd get the full credit for it at this point. But just to make sure, I will continue solving this for the sake of anyone who wants to go through them all. So we have a 5x cubed minus 9x squared minus 7x plus 1. So that's 5, -9, and then I think it was 7 and 1, or -7 and 1 for the coefficients. And our denominator is x squared minus 4. So because our numerator has a degree 1 higher than our denominator, we are going to have what we call a slant asymptote. So there's a line coming through here. We also seem to have a vertical asymptote. We'll actually have two of them. We'll have x equals 2 and x equals negative 2. These will both be vertical asymptotes because these are where we divide by 0, and these factors do not cancel with any factors in the numerator. They can't, because if they did, our constant in the numerator would have 2 as a factor, and it does not. So we're going to have x equals plus or minus 2. That gets us A, C, or D. And our slant asymptote seems to have the positive slope, so that's the 5x minus 9. You can see that going through here. So the x-intercept here, we've got 3 of them. And those 3 are consistent for the most part. We see there's a little bit of a sign difference. Okay. So the only negative one is the 0.68. The others are positive. So that leads us to option A. And the y-intercept is at 0 and the negative 0.25. So that's consistent as well. Now this one, simplifying this as much as possible. Well, this is interesting, right? What does this continuing fraction simplify to? Continuing fractions get a little more complicated than we usually want necessarily in high school. We can actually deal with these. So one way we could deal with this, we see that we have a negative 4 in every numerator and a 4 plus leading into it. So let's activate our scratch pad. So if x is our continuing fraction, that's a negative 4 over 4 plus. Well, now we have another x because we have that continuing fraction there, the negative 4 over 4 plus, negative 4 over 4 plus, and so forth. So now we can solve this as a quadratic. So we have a 4 plus x times x equals a negative 4. 4x plus x squared is a negative 4, or x squared plus 4x plus 4 equals 0. That factors as x plus 2 squared. So x is a negative 2. Sorry, I did not mean to hit that one. But negative 2 is the value of that fraction. So here we want to find the vertical and horizontal asymptotes of this function. So again, we can graph it. For the vertical and for the horizontal ones, notice that the degrees are equal. So as x gets very, very large, the plus 5 and the minus 16 don't really matter. And this fraction simplifies to 4x cubed over 2x cubed, which simplifies to 4 over 2, which is 2. And 3 minus 2 is 1. So our horizontal asymptote is y equals 1. That's enough to uniquely determine it. To find our vertical asymptote, we factor the common factor of 2, have x cubed minus 8, which tells us that x cubed equals 8 is where we get a vertical asymptote, or x equals 2. All right, so here we are going to have vertical asymptotes at x equals negative 2. So that is either B or D. Now we're looking for the x-intercept. Or actually, let's find the y-intercept. That's easier because that's where x is 0. If we let x equal 0, y equals 7 over 2 squared, which is 7 over 4. So we are going to have the asymptote at x equals -2 and our y-intercept at 7/4 and not 3/4. So we now have our 10 correct. We have the option for the memory boost, but we don't need to take that right now. So we will stop for now after the 10 questions right. And now this step is absolutely vital. We must turn it in. We have to click turn in, or I cannot see the assignment. And now it tells you, now again, this score of 100% just says we get 10 correct. But I am looking for this mastery level. You can have a bar in the red because you get 10 correct and 20 incorrect. And CK12 will tell you it's 100%. That is not the way I am scoring it. So keep that in mind. I am scoring it based on this mastery skill level here, which also means if you hit that after 6 questions, you can stop, turn it in, and be done. You don't need to do the 10.